right, guys. Sorry about that. Like I said, I'm learning. So here we go. Let's just keep going then. We've already determined that there are two options for having a male and female cat, and that 2 out of 4 is a 50% chance. Hey, look, a tree diagram. So right here, okay, so right here, we're talking about the different options. The first kitten could be a boy, and then the second kitten could be a boy or a girl. And so here we want to focus on the highlight. This is one of the favorable outcomes. And then the second cat, if it's a female, then the other one, I'm sorry, the first cat, if it's a female, the other one could be a male or a female. And so this right here, again, is the favorable path. And so there are 2 out of the 4 total outcome possibilities. There are 2 of them that are favorable. All right, let me get my mouse pointer back up. There we go, and we can move on. I guess I do need to erase that myself. All right. Yeah, I don't know that I'm going to be using that so much, but it was worth a try. All right, so again, with and without replacement, you can see how these tables are different. The first one, you can choose a blue, a green, or a white marble. And then if you put it back, you can, again, choose a blue, green, or a white marble. These tree diagrams, they're just very intense to make, especially whenever we get when we get a little bit further on and start talking about pizza and toppings. So draw a tree diagram to show the sample space for all possible gender outcomes for a litter of kittens. Okay. Never in my years of state testing have I ever seen anyone have to draw a tree diagram from the beginning. They had to fill in some blanks over here, and so they needed to understand where this would come from. But this isn't really that horrible, I guess. So there's 2 possibilities, right? For the first one, it's going to be a boy or a girl. And then there's the second kitten, and it's going to be a boy or a girl. And then there's the third kitten, and it's going to be a boy or a girl. And so it's got 3 levels of the tree. And so there are still only 2 options for outcomes. So we've got boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl. Those are independent events, and they do not depend on each other. Gender of one sibling is not dependent on the gender of the other. What is interesting, though, is that there are, in very large families, you can really see the trend that a particular couple has in boys or girls, and it's very interesting to look at that biologically, but we're not going to go there too much in depth. So yeah, this is that. And I wonder if this works like my smartboard where I can just circle everything and then erase it. I can't even make a circle. Okay, yeah, no. All right, so we're just going to erase that really quick. And then we're going to move on super fast because it's already time to go. So again, modeling tree diagrams to understanding problems. Again, on a die, there are 6, and they need to have a sum of 7. So 6 plus, sorry. Jess and Dave are playing a board game. They roll 2 number cubes, roll even numbers. 2 even numbers for Jess, and Dave needs to roll 2 numbers with a thing of 7. Okay, so this is Jess. Everything needs to be even. 2 even numbers. Why is it only highlighting? Now I'm confused. It says that she needs to roll 2 even numbers. Does that mean 2 numbers that are the same? It probably does, because that's what's highlighted down here, and that's That's silly. I'm not in love with that. Okay, that wording. It's very weird because even numbers are like numbers that are 2, 4, 6, and 8, So, okay, that's strange, but whatever. And so that's why these ones here are highlighted. The 6 and 6, the 5 and the 5, the 4 and the 4, the 3, the 3, the 2, the 2, the 1, the 1. Yeah, we call that rolling doubles. But okay. And then here are Dave's favorable and possible outcomes. So the favorable ones are 6 and 1, 5 and 2. So you can just list out all the possibilities, I guess, all the possible outcomes, and then go back through and highlight the ones that actually make 7, because that's what he needs. And so on this one, it'd be 1, 2, 3, 4, 5, 6. So there are 6 possible outcomes out of this table of 36. And so that's what it would take for him. 6 out of 36 is 1/6. Okay. So other questions, these are just things to think about. You don't have to spend a lot of time on that. Here's some other questions that you can look at. Finding probabilities of compound events. So again, that's what we've been doing the whole time, is actually breaking this down. So this is pretty simple to get through. If you have any questions, please make sure that you email me. And then compound probability with more than 2 events. So here we go. You can have a pizza, and you have to choose the size. So that's 1 event. And then you can choose a meat, which is 1 event. And then you can choose a vegetable, which is your last event. And so looking through here, what are the favorable outcomes? So looking at the question, what's the probability that someone will order a pizza with sausage and peppers? And so you would go through and highlight all of the pizzas that have sausage and peppers on it. And I guess that would be easier to do with one of these. So a small sausage with peppers. A medium sausage with peppers. A large sausage with peppers. And those are your favorable outcomes. And so if someone just randomly goes up and decides, what kind of pizza they're going to choose, well, we can actually see all of the outcomes just by looking at the last column. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18. There are 18 total possibilities, and 3 of them have sausage and peppers. Oh, I missed the both part. Silly me. So yeah, that's what it takes to actually, read the problem. And so it could also go this way: sausage or small both with peppers, and small both with peppers, and large both with peppers. And so now there are 6 total outcomes out of those 16, right? We said 16, 2, 4, 6, 18. So 6 out of 18 is 1/3. And so they got a 33% chance of choosing a pizza with all that stuff on it. Okay, I'm going to leave those lines there really quick. There's another one of those type problems. I feel like we did several of these last year. We talked about, cafeteria choosings, that you could pick a burger or a meatloaf, and you could pick tater tots or French fries, and you could pick chocolate pudding or vanilla ice cream or something like that. We talked about this last year. I remember that. I was there. Not all of you, though, were. So if you have any questions, please make sure that you email me. All right. I've been talking for a long time now, and I'm going to stop. Please attempt this right here, and then your homework page in the problem and problem solving book is written on that document from yesterday, which you can still access. All right. You guys have a great rest of the day, and I will see you tomorrow.